Hello everyone, welcome to the channel. I'm Prashant Thakur and this is actually my first video on YouTube channel. On this channel, I'll be solving LeetCode problems and explaining the intuition behind the solution so that we don't just memorize the code but actually understand the patterns, understand the pattern behind every problem. So today we are solving LeetCode daily challenge, minimum cost of buying candies with discounts. So yeah, so let's first understand the problem statement. So the problem statement is a man is selling candies at a discount. For every two candies sold, the shop gives a third candy is free. So let's suppose you have you are on shop, yeah, and if you buy two candies, then you have a chance to buy chance to get a third candy free if you fulfill some conditions. So what are those conditions? The customer can choose any candies to take away for free as long as the cost of the chosen candies is less than or equal to the minimum cost of the two candies bought. Means if you buy two candies, then you get a that candy free whose price is less than or equal to the minimum of the two candies which you purchased. Okay, so for that we have given a zero indexed integer array cost, and cost of I denote the cost of candies, and we have to return the minimum cost of buying all the candies. Means we have to buy all the candies with minimum cost. That is our answer. So let's first understand problem with much more clarity. So yeah, so suppose if you buy 6 and 5, then there is a chance of chance, or you can say two candy is free because its price is less than its price or value less than 6 and 5. Okay, if we purchase 7 and 9, then we have a chance to get a free candies 2, 5, 6, but we choose 6. 6 why? So let's suppose you are in a shop and you have a chance to get a free candies of worth rupees 20 or 20 and 200. So which one you buy, for which one you get free? Definitely, definitely you purchase the candy which has higher cost, buying cost. Now means if you get a free candy of worth rupees 200, then like do you don't have to spend more money to purchase all two candies. You have to just pay 2 rupees. No, okay. So yeah, so our objective is to objective objective is how can we maximize the value of the candies that become free. Okay, candies 6 and 5, then we can only uh, only get a free candies of worth rupees 2. Okay, and our cost and, and cost is 6 plus 5, which is 11. Okay, and then 9, then 7 and 9. So after that we can, so cost 7 plus 9, yeah, so it's 27, and this is, and decrease on this. So our array looks like 9, 7, 6, 5, 2 and 2. And now if you make a pair of 3 elements, 3 and 3 elements, and 7, then candy, 6 is free. So our cost is 9 plus 7, which is equal to 16, and when we buy 5 and 2 can 5 and 2 candy. Okay, so our cost become 16 plus 5 plus 2, which is equal to 16 plus 5 plus 2, 21, 23. So yeah, and it is less than this one. Okay, so here we can observe one thing, that if we sort the array in decreasing order, then every third candy become free. Group them 9, 7, 6, so it looks like it's follow the order: highest, second highest, third highest. So it is always mandatory that third highest is less than the highest and second highest element, so it always free. So during the purchase, we just do pay free, pay free. Okay, and so on. Hopefully you understand the key observation. This is the whole crux of the problem. Short array in decreasing order. Okay, and 2 traverse the array, add cost of every candy except third candy, because third candy is always free. Now try to solve this problem by yourself without seeing the coding implementation part of this problem. Okay, so let's code this problem. So first we sort the array, sort array in decreasing order. So for sorting we use inbuilt sorting, cost dot begin, cost dot end, greater int. Okay, and now traverse the array, but before that make a answer and cost variable, and initialize it with 0 value. Okay, and now traverse the array. So for int I equal to 0, I less than equal to cost dot size. Okay, and I plus plus. And if I is 2 comma 5 comma 8 and 11. So we skip it because I skip it because they all are free. And so if I modulo 3 is not equal to 2, then minimum cost is equal to cost of I and return cost of I. So okay, so there is a typo error. Okay, and one more thing, I modulo 3 gives 2, 5, 8 and 11, which we have to avoid. Okay, so that's why we write this condition, I modulo 3 is not equal to 2. Let's sum this problem. Okay, so that's it. Okay, and let's try run this problem. Okay, so let's try run this solution. So initially our cost array looks like this, but after sorting in decreasing order, our array change into 9, change into decreasing order. So 9, 7, 6, 5, 2, 2. Okay, and we initialize main cost variable from 0 and I is equal to 0. Condition is I modulo 3. Okay, so first I value is 0, which is represent the first element of the array, and yeah, 0 modulo 3 is 0, which is not equal to 2. So we add first element in main cost into the main cost. Okay, so 9, and I value increases to 1, 9 I and I plus plus. So so 1 modulo 3 is equal to 1, which is not equal to 2. So we also true. So this condition is true. So we also add 7 into the minimum cost, 7, and now I plus plus. So I becomes 2. But here is the condition that 2 modulo 3 is 2, and which is equal to 2. So we do not take values on index 2 because we know that 6 candies is free. So again I plus plus, okay, I plus plus and 3. So 3 modulo 3, which is equal to 1 and not equal to 2. So we add value, add this value, so 7. Okay, so add 5 plus okay, so again I plus plus, so which is 4, and which is 4, and 4 modulo 3 is 1, which is not equal to 2. Oh sorry, here 0, so 0 not equal to 2. So we add 5 into the minimum cost, and similarly 5 modulo 3 is 1, which is not equal to 2. So we also add this value, means 2 into the minimum cost. Okay, and now I plus plus and I becomes 5, 5 and 5 modulo 3 is equal to is 2, which is equal to 2. So we avoid this value, and our I plus plus and I become 6, I become 6, which go out of bound, means out of bound. Okay, here our loop stop, and our answer is then cost 5 plus 7 plus 5 plus 2, which is 23. 5 plus 9, 16, 16 plus 5, 20. Okay. And talking about time complexity, so it's take the order of n log n, and here time for complexity is order of n. So our overall time complexity order log n, where and talking about space complexity, so we don't use any extra space, so our space complexity is order of 1. Okay, that's it for today's problem. Since this is my first video on YouTube, I'd really appreciate your feedbacks and comments. I'll be uploading more LeetCode solutions regularly. Thanks for watching. See you in the next problem. Happy coding.